Hi everyone, this is Anushka and welcome back to my channel A in Economist. So in today's video, we are going to cover a very crucial topic in your advanced econometric syllabus, which is known as the instrumental variable, right? Instrumental variable, whether you are a postgraduate student or you are a researcher, PhD scholar of economics, this instrumental variable topic is very crucial for you. You will use this in every step of your research, right? So this is very crucial. This is one of the most powerful techniques which is used by econometrician. So what is the agenda for this video? We will discuss why do we need instrumental variables. In short, we call this as IV, right? So we'll discuss why we need IV. This is the first thing that we will discuss. Now, the second thing is that we will discuss the three different sources of endogeneity that will lead us to use IV method, right? So when in which of the situations IV variable is a requirement that we will discuss in details. We will go into the examples also. And the third thing that we will discuss is how do we do the estimation if instrumental variable is present in our model, right? So these are the three different things that we want to discuss in today's video. Now let's get started. So first point, as I've told you, why do we need IV? Why do we need instrumental variables in the first place? The main issue that we will face here is the problem of endogeneity. Something called endogeneity. The problem of endogeneity is very important for you to understand what is endogeneity. So for that, see here that instrumental variable estimation is a powerful technique in econometrics used when the exogeneity assumption of ordinary least square is violated. So what is this? Suppose we have a very simple two variable regression model. Suppose I call this alpha plus beta xi plus epsilon. And this is the simplest regression model that we have. Now, if you remember, one of the assumptions of OLS model was that the covariance between this explanatory variable and the error term, this has to be exactly equals to 0 for all I, right? This is one of the assumptions. I have made a separate, video for assumptions of OLS. If you haven't watched that video, I'll give the link in the description. Please check that out. So there we have discussed in details that we have assumed that the explanatory variable in our model has no correlation with the error term, with the stochastic error term, which is one of the basic assumptions of OLS, which is also known as the exogeneity assumption, right? This is called the exogeneity assumption. If this assumption is satisfied, then we say that xi is an exogenous variable, right? If this assumption gets satisfied. If this holds, we will say that xi is an exogenous variable. Now, what happens if this assumption fails? If this assumption fails to hold, suppose I say that for a regression model like this, covariance of xi epsilon I now gets correlated with each other. If this kind of correlation arises, then we are violating the exogeneity assumption, right? If this kind of correlation exists between the explanatory variable and the error term, then we are explicitly violating the exogeneity assumption, which is a necessary assumption for the OLS regression to be holding, right? OLS, ordinary least square method to be efficient, this assumption is needed. But if exogeneity assumption gets violated, then the problem of endogeneity arises. This is the condition for endogeneity. This is the condition for endogeneity, that the explanatory variable becomes correlated with the stochastic error term. Now, if this is the scenario, then we say that the explanatory variable of our model, this xi, is now become endogenous. It's now becoming endogenous variable, right? It becomes an endogenous variable. And if endogeneity is present in our model, and still you are using ordinary least square method, then what you will get is biased and inconsistent estimates, right? If endogeneity problem is there in your model, that is one or more variables, explanatory variables of your model are endogenous in nature, but still you are using OLS method, ordinary least square method for estimation, then the estimation will become biased as well as inconsistent, right? Biased as well as inconsistent. And to avoid this, problem, we need instrumental variable. So instrumental variable estimation is used directly to handle the problem of endogeneity. In the presence of endogeneity, if you introduce certain instrumental variable and do two-stage least square method, then the estimation that you will get, the coefficient estimation that you will get will become consistent even in the face of endogeneity problem. Right? I hope this much is clear. If you have any questions in this, you can let me know in the comment section, right? So here I have written, see, IV helps to recover consistent estimates even in the face of endogeneity problem. So this is the basic thing that you have to understand. So please understand what is an exogenous variable and what is an endogenous variable. Your understanding of instrumental variable will depend on these two things, right? On these two concepts, what is exogenous variable? Exogenous means there is no correlation between the explanatory variable and the error term. There is no correlation. Correlation is basically covariance is equals to 0. But if the problem of endogeneity arises, then this covariance will become not equals to 0, which means that the explanatory variable has some sort of correlation, with the stochastic error term, and that is why the explanatory variable in our model is now endogenous. So this is a direct violation of the assumption of the classical linear regression model assumptions. That is why OLS estimation method is no longer valid, because if you apply OLS, that will give you bias and inconsistent estimates. To avoid this problem, we need to go into the instrumental variable as a different approach, right? I hope this much is clear. Now understand what is this instrumental variable and which variables you can say that is qualified for instrument, for working as an instrument. So see here, an instrumental variable we usually denote it by Z. By Z, we usually denote, this is a standard notation of instrumental variable. So an instrumental variable Z is a variable used to isolate the exogenous variation in an endogenous regression X to estimate its effect on the outcome variable. So when we will go into the two-stage least square method, you will understand this line even more, clearly. As of now, understand that for a variable to qualify for being an instrument, you need to primarily satisfy two different key conditions. As of now, understand this. Later on, when I'll go into the two-stage least square method, I'll explain this again in details, right? So for a valid instrument, you must satisfy two key conditions. What are the conditions? Understand this. First condition is the relevance. First condition is known as relevance, which basically means like this. Suppose the model, let us take a simplified model. Suppose this is the most simplified model that we have. Now, in this model, suppose we consider that xi and epsilon I is correlated with each other, which basically means xi is an endogenous variable. That is why we need this instrumental variable. Now, the instrumental variable, how do you define this instrumental variable? Suppose Z is an instrumental variable. So what is the condition? Z is an instrument means Z should have a very high correlation, very strong positive correlation with the endogenous variable or endogenous explanatory variable of our model. So this is quite obvious that if you are using this instrumental variable as a proxy, if you are using this variable as a proxy of this xi variable because you want to avoid the endogeneity problem, then definitely this instrument Z should have a very strong correlation with this xi variable, right? X variable. That is the first condition. That if you are using Z to be the proxy of xi, then definitely Z should explain certain variations of xi, right? So that is what I have written here also, that Z variable is used to isolate the exogenous variation of the endogenous regression X. So Xi should have certain variation, some variation. The total variation of Xi can be related to two different things. First is some variation will be related to the exogenous terms, exogenous part which will be extracted using this instrumental variable, and another part of this variation will be related to this. This is the problem of endogeneity. We want to avoid this problem. That is why we are introducing this Z variable. So the exogenous variety, or the exogenous variation of this X variable can be found out if we can find out an instrument such as Z, which is a strong correlation with this xi variable. So this is the first condition for being qualified as an instrument into the model. So the first condition is the relevance condition, that covariance of z and x has to be strictly not equals to 0. So z and x has to be strongly correlated with each other. This is the first criteria. And the second criteria is the exogenity. That the z, the instrument that we have defined, it cannot be correlated with epsilon I, right? It cannot be correlated. So what I am saying is that, so suppose we introduce the variable zi is the instrument. So this zi should have a strong correlation with this endogenous variable xi. That will help us to find out the exogenous variation of xi. But this zi should not have any sort of correlation with this error term. If this is correlated, then again Zi will also become endogenous, right? If Zi and epsilon I are correlated, then Zi will also become an endogenous variable. That will not, then Zi will not be qualified to be an instrument. For Zi to be an instrumental variable, we need that Zi itself is an exogenous variable. Exogeneity property has to be satisfied. So covariance of Zi and epsilon I has to be equals to 0. But there should be a strong positive correlations, very strong correlation between xi and zi. That will help us to find out the exogenous variation of the endogenous regressor x. So if these two conditions are satisfied, then we will say that z is an appropriate instrument that can be incorporated into the model, right? If these two conditions, these are the two key conditions, this has to be satisfied. Only if these two conditions are satisfied, then only we can say that Zi is a valid instrument to be incorporated into the model. Now, understand one thing, Zi is not correlated with epsilon I. It in turn implies that Zi is uncorrelated with yi also. Please pause the video and, try to, understand this thing, what I am saying. If we are saying that this Zi variable is uncorrelated with epsilon I, which is indirectly saying that Zi and yi will also not have any sort of direct correlation. If Zi is correlated with yi, if Zi is correlated with yi, then and yi is correlated with epsilon I, then Zi will also be correlated with epsilon. Right? If Zi has some correlation with yi, and we already know by the regression model that yi has an association with epsilon I, yi depends on epsilon I, then we can say altogether we can say Zi also depends on epsilon I. And if Zi depends on epsilon I, then again this exogeneity criteria is getting violated. So Zi cannot be an instrument, right? So indirectly we are saying that Zi is also uncorrelated with the outcome variables. So Zi is purely an instrument. Instrument means it will only be correlated. It will only be correlated with the endogenous explanatory variable. It will neither be correlated with epsilon I. It will neither be correlated with the outcome variable. Right? These are the two basic things that we need to understand very well before going to further discussion. So this is about the IV method, right? Instrumental variable method. So we have understood when should we use the IV method, that is when the problem of endogeneity is present, exogeneity criteria is violated, and the second thing that we have assumed that what is IV. When will we say that the Zi variable is a valid instrument, right? These two things are clear. Now let us move to the third point, which tells us that when will this endogeneity problem will arise. So primarily, there are three key sources of this endogeneity problem. Primarily, three different sources are there when the OLS assumption, OLS will fail as an estimation method, right? OLS will fail or the classical linear regression model assumptions get violated in three different scenarios primarily. And in these three different scenarios only, we need the instrumental variables as a solution technique, right? So let us understand that the first thing that I have written here is the omitted variable bias. In the situations of omitted, so this comes under the specification error topic, which I have, done in details. If you find out this is the playlist, this is the advanced econometrics playlist in which you will find this omitted variable bias, what will be the consequence in details. I have full length lecture video on this. Again, if you haven't watched, if you are new to my channel, please check this out. You will get this concept even more clearly, right? So when omitted variable bias exists, so for example, suppose our true model is like this. Suppose the true model that we have is this: yi equals to beta naught plus beta 1 xi plus say beta 2 some wi plus epsilon I. Suppose this is our true model. I is from say 1 to n, right? This is our true model, but due to some mistake, as we always say in case of omitted variable, we are mistakenly omitting some of the crucial variables. So suppose this wi variable we forgot to include. It can be due to lack of information about this w or due to simply carelessness of the researcher. We simply forgot to include this wi variable. So wrong model looks like this. Yi equals to beta naught plus beta 1 xi plus ui for all I equals to 1. Right? So this should be the model, this should be the original model, but due to some mistake, we have completely omitted this wi variable, right? We have completely omitted this wi variable. Now, if this wi variable is completely omitted, then what can you say? What can you say? If you look at these two models, true model and the wrong model, what is the first observation that you can make? Can you please pause the video and think? What is the first observation that you can take? Where will this wi will go? Where will this wi go? The simplest answer is that the wi will be included in the error term, right? If you simply omit one variable which should be present in the model, but you are completely eliminating them, omitting it, then what should happen? This random error term in the new model or in the incorrect model should include that term. Whatever thing you are, so this random stochastic term is introduced only for this reason, that whatever terms are missing, you are taking them into account using this ui, right? Using this stochastic random term, we are taking into account all the variables that we should have included, but due to some reason we are unable to do so because we don't want to make our model complicated or due to some other reason. So this error term, this random error term captures all the uncertainty. It captures all the randomness in terms of all the missing variables. So this wi variable will be added here. This wi variable, so ui term, this ui component will have this wi term in it, right? Now, if we know this, now suppose our xi term becomes correlated with wi. Suppose xi and wi gets correlated. Now, if this is the scenario, what we can say? If this is the scenario, what we can say? This we are saying that xi and wi are correlated with each other. If xi and wi are correlated with each other and wi is contained in this ui, so what we can say? Covariance of xi and ui in our incorrect model will be not equals to 0. This will be not equals to 0, which will make xi to be an endogenous variable. That is how endogeneity will be introduced in our model, right? Now, if you apply OLS in this method, what will happen in this model? If you apply OLS to find out what will be beta 1 cap, this will be biased and inconsistent due to the problem of endogeneity. See, endogeneity is introduced. I hope you got the process, how the logic works. So let me repeat it again. Suppose this xi and this wi, these two variables get correlated with each other. And as I've told you, this wi variable is in this ui, right? Wi is in this ui. So this directly means that xi correlated with wi means xi is correlated with ui also, because ui and wi are correlated, right? Wi and ui are correlated, and if xi has some sort of correlation with wi, then xi will be directly correlated with ui. That is what will make xi the endogenous variable in our model. Thus, the problem of endogeneity will arise. And if instead of this endogeneity, if you apply OLS method in this incorrect model, then the estimate that you will get, this beta 1 cap, this estimate that you will get, it will be biased and inconsistent. That is why we need instrumental variable. And here we can directly measure what will be the bias, what will be the amount of bias. The amount of bias in this model will be simply this. This beta 2 will be there. This beta 2 is there into the amount of correlation, that is the covariance between xi, wi upon variance of xi. So this will be the amount of bias, exact amount of bias that we can measure from here, right? So this is the mathematical form of the bias that we can get from here, right? If this bias is present, then in order to remove this bias, and to get consistent estimates, we need to apply the instrumental variable approach, right? Now let us see how we can incorporate this instrumental variable. Let us take a very simple example. Suppose we have the equation as this. Suppose we are measuring the wage equation, right? Suppose wage I is alpha plus beta education. Education plus say gamma ability. Ability plus some error term, this. Error term say I, and here also you have I. Right? This is your true model. Suppose this is the wage equation. And what we are saying is that wage depends on the education level of the individual and also on the ability of the individual. This is our true model. Again, due to some mistake, suppose we do not have any information about the ability, right? We do not have any information about the ability, so we simply omit the ability term. Suppose we do not have any information, so we completely omit it basically. But what we know is that, ability affects both the education and the wages, right? And the wages. So basically, what is the intention? Intention was to determine the wage of an individual I, and we have assumed that wage depends on both education and ability. But due to lack of proper information or proper metric, suppose we omit this ability, but we know on the back of our mind, we know that the ability affects both education and wages. So clearly the problem of endogeneity is present in our model, right? Clearly the problem of endogeneity is present in our model. So in this situation, what we can do, we will take the help of the instrumental variable. Right now, what should be the nature of the instrumental variable? We have to define an instrument. Suppose Z is an instrument that we have to find out that will have a strong correlation. With education, right? That should have a strong correlation with education, but that should not have any correlation with the error term or with the ability itself, right? This is the intention. We should find out an instrument Z which will affect the endogenous variable. Suppose education is here education is definitely an endogenous variable, because see, education and epsilon I will get correlated. Why this is so? Because if you omit this ability term, ability will come here, right? If you omit this ability term will come into the error term. And again, education and ability are strongly correlated with each other. So in turn, it means that education and epsilon I will be strongly correlated with each other. The direct logical reasoning that I have given you here, right? It is the exact logic that I have given you here. If this is the case, we know that a positive bias will exist. And you can count this. Exactly what will be the bias, you can count this also. So if this is the scenario, what we need to do, we need to find an instrument Z that will affect education, that will have a direct strong correlation with education, but that will not have any correlation with the ability or the error term of this wage equation. Now, can you pause the video and think of an instrument? Think of such an instrument which has strong positive correlation with education, but it will not have any correlation with ability or with the error term. You can pause the video and think. I have, given a thought. I got an instrument like this. Suppose it is the proximity. It is the proximity to the college. Right? This can serve as an ideal instrument in this particular case. Right? Can you understand this thing? This is the instrument, proximity to the college. So here, if Z is the instrument, then the covariance between The covariance between proximity and education is definitely there. This is not equals to zero, so a strong correlation exists, right? Proximity to the college has an impact on education, so this is strongly correlated with that. But the proximity does not have any correlation with the ability. Does not have any correlation with the ability. So this will make Z, that is the proximity to the college, and valid instrument. So this will act as a valid instrument in this particular case. And if you introduce this particular instrument, then you will get consistent estimates of this beta coefficient, right? Unbiased and consistent coefficient of this beta coefficient can be obtained if you introduce this kind of the process. I'll tell you the process. I'll go into this in a while, but understand that this could serve as a valid instrument in our particular scenario. So this is the case when omitted variable bias will lead to introduction of instrumental variable in our model. So this is the first case. Now let us go to the second case, which is even more interesting, which is the case of simultaneity bias. This simultaneity bias, I'll make a separate video on simultaneous equation model. This is the agenda for the next successive videos. So we'll discuss this there also. As of now, just take it from me. What is the concept? Simultaneity bias occurs when there is mutual causality. Mutual causality is present. Mutual causality, or you can say bidirectional causality. Bidirectional causality is present, right? When mutual causality or bidirectional causality is present, simultaneity bias occurs. So it basically means X affects the variable Y, but Y also affects the variable X. If this is the scenario, right? X affects Y and Y also affects X. If this is the model, then we will say X will cause Y and Y will cause X. So that is the mutual causality. X is causing Y and Y is also causing X. That is the bidirectional causality or mutual causality. For example, you can take it as a model. Suppose the model is this. Yi is say beta naught plus beta 1 xi plus epsilon I. Suppose this is the first equation, which we also call as the structural equation. Suppose this is the structural equation that we have. And there is another equation which says xi is gamma naught plus say gamma 1 by I plus vi, which is also known as the simultaneous equation. Simultaneous equation. Right? So these two equations compose the entire model. This is the first equation, this is the second equation. Now, in this particular scenario, what we can say, can you find out the chain of reasoning which will lead us to the endogeneity problem? Can you pause the video and think? How can you show that here the endogeneity exists? So the chain of reasoning will be simple. So start with model number 2. In model number 2, what we see is that xi is a function of yi. See, xi is regressed on yi, means xi is a function of yi, right? And in the first model, what we see that yi depends on epsilon I. In the first model, what we see, yi is a function of epsilon I. So if you combine these two information, what you can say? If you combine these two things, what you can say, xi and epsilon I in the first equation will be correlated with each other. See, can you understand this thing? I know if you are someone who is, studying this for the first time, it may seem a little hard, but if you, give it a think, if you give it a thought, then you will see that it's not that complicated. So it's simple, it's logical. See, xi in the second equation depends on yi. Xi is a function of yi. Again, yi in the first equation depends on xi and epsilon I. If yi depends on epsilon I, then what we can say? yi dependent on epsilon I and xi is dependent on yi, which directly means xi is also a function of epsilon I. xi is also a function of epsilon I, which directly means, which infers this, that covariance of xi and epsilon I is not equals to 0 in case of the first equation, which means xi is endogenous. Xi is endogenous. Now you can do the similar thing, exactly the same thing for yi also. We will see yi is also endogenous here. Let me show you how. Let me show you how this is happening. So here now start with the first equation. In the first equation, yi is a function of xi. Exactly the reverse will be true, right? Yi is a function of xi. Now in the second equation, if you see, xi is a function of vi, that is the error term, which directly means in the second equation, yi and vi will get correlated. Yi and vi will get correlated, which basically means that yi is also endogenous. So in our model, both xi and yi are endogenous variables. And since they are also the explanatory variables, so see here what is the unique thing is that the independent variable of one equation is the dependent variable of the other equation. See, xi is both independent and dependent. Yi is both dependent and independent. So that is the basically causality bidirectional. Bidirectional causality, the dependent. So there is a presence of feedback loop here, right? We say it is the feedback loop that is been present, which makes both the variables endogenous in nature. So both xi and yi are endogenous in nature. Again, the problem of endogeneity arises. That is why we need instrumental variables. So again, so when simultaneity bias is present, then also we need instrumental variables, right? This is the second thing. Let me show you an example for this. The most simplest example that you can take is the demand supply example. Most simple example will be the demand supply. Suppose I consider demand and supply of, say, some products in milk. I assume demand, you can take anything. I'm just giving an example. Suppose I consider demand and supply of milk. Let us start with the demand equation. Suppose the demand equation is this. QD is equals to alpha minus beta P plus say U. This is the demand equation, and the supply equation is like this. QS equals to gamma plus delta P plus say V. Right? So this is the demand equation. This is the supply equation. Now by the simple demand supply law, at market equilibrium, what will happen? At market equilibrium, we will equate the quantity demanded with the quantity supplied, and we will get quantity as a function of price. Quantity as a function of price, but since here see P is the endogenous variable, P is the endogenous variable, so bidirectional causality is again be present. So price is also dependent on the quantity. In demand supply, what we know is that quantity demanded has a correlation with price. Price also affects quantity. So there is a bidirectional causality. Can you observe this? Quantity demanded depends on price. Again, price is dependent on the quantity demanded. Similarly, for supply, quantity supplied depends on price. Price also affects the quantity supply. So if you follow the market equilibrium, then quantity will be a function of price, but price will also be a function of quantity, right? Price will also be a function of quantity. So what we can say, so if we try to estimate, the quantity to be this, suppose quantity, I regress quantity on price. Suppose I regress this model, then price will not be exogenous. Price will not be exogenous because it is also determined. It is also determined by the quantity, which in turn includes the demand shock, which includes demand shock, which includes the demand shock, which is denoted by U in our particular model. So again, the same thing. See, quantity depends on price, but price also depends on quantity. So P is not an exogenous variable here. If you regress quantity on price, this will give you again biased and inconsistent estimate of theta 1 cap. So that is why we need to introduce the instrument. So because it is also determined by quantity, it includes the demand shock, and that's what we can say. We can say that this basically implies that covariance of price and epsilon, if you take, it will be strictly not equals to 0. If this is the case, P will become an endogenous problem. So the problem of endogeneity will again arise. Price will be an endogenous variable. Now, can you think of an instrument for the price? Can you think of an instrument for the price? This is the final thing that we need to understand here. What could be a potential instrument? The potential instrument could be in this supply equation. Suppose instead of price, I write the input prices. Suppose I introduce an instrument. Instead of the product price, we suppose we introduce an instrument which is the input price. So input price is definitely a good proxy of the original price, because the market price will be set depending on the price, the cost of the production that will be determined by the input price, right? So Z is such an instrument. Z is such an instrument which has strong correlation, with the price, but it does not have direct correlation with the supply or the demand. So basically, the correlation between Z and U and Z and V. So ZV, this correlation is not present, but Z has a strong correlation with P. That qualifies the input price to be a good instrument or a valid instrument in this case. This is also known as the cost shifters. In case of demand supply scenario, we use the cost shifters as an instrument. Cost shifter. This will denote the cost shifter as an instrument for the price, and this shift the supply. This will shift the supply, but not the demand, right? So this is also an application of the instrumental variable. And the final thing that I wanted to share with you, the third source is known as the measurement error. Third source is known as the measurement error. Again, this comes under the specification error thing, which I have discussed in details in the previous videos. I'll give the link, please check that out. So in case of measurement error, what happens is that we assume the model to be this. Suppose yi is beta naught plus beta 1 x I star plus epsilon I. Suppose this is the model. But we observe, that xi is measured with some error, which can be denoted as this, right? So xi, here we are introducing the measurement error in the variable x, and we say that we observe, this is the model, but we observe xi to be with some error, right? Xi is, see here, this new I term is the measurement error. So if this is the, let me write it down, mu I is known as the measurement error here. This we have done before. Measurement error. Now, if this is the scenario, what we can do? Simply replace this into the original equation. So beta naught plus beta 1. Instead of xi star, what you can write? Xi minus mu I. Right? From this you can substitute. So do that. Xi minus mu I plus this error term is as it is. If you rearrange, this will be beta 1 xi comes out. This will be epsilon I minus beta 1 mu I. Right? So this is the thing. Now again, the explanation goes in the same way. This is the composite error term. This we have seen before. This is the composite error term that we will get here. Now, what you can say, what is the relationship of this composite error term with xi? What you can say, this will be simply not equals to 0. The covariance of xi with this composite error term will be strictly not equals to 0. Why this is the case? Because the reasoning is simple. See, xi depends on mu I. Here we have defined that. Xi clearly depends on mu I. So if you take this covariance, that will be simply not equals to 0. See, xi and mu I, they are correlated. So mu I comes into the composite error term. Mu I comes into the composite error term, which will make, again, the explanatory variable gets correlated with the error term, which means again the problem of endogeneity arises. Again, the problem of endogeneity arises, and here a special kind of bias arises. Here a special kind of bias arises, which we call as the attenuation bias. Attenuation bias arise. What is attenuation bias? Attenuation means if you do the estimation using OLS, the OLS estimator of the beta coefficient will be biased towards 0. If you find out this cap, right? If you find out this beta 1 cap corresponding to this endogenous variable xi, the estimated value of the beta 1 cap will go towards 0 basically. It will go towards 0. That is something called the attenuation bias. And again, we can, clearly define the bias here. What will be the bias? The exact structure can be defined. This will be beta 1 into sigma x star squared upon sigma x star squared plus sigma mu squared. And this will be less than beta 1. This will be always less than. The direction of the bias can also be understood, that it will be always. So the underestimation will take place. If you have measurement error in your model and still you are using OLS, then the bias will arise. Definitely bias will arise because the problem of endogeneity arises. Not only that, the bias will be underestimating the original coefficient. So the underestimation will take place. Right? You cannot find out the original estimation value of the coefficient, but an underestimated value will be obtained, and this will be the amount of bias that you will generate. Right? Again, we can take some example for this. Suppose in a survey, in surveys, self-reported income, suppose I call this to be X, often has error. Often has error, which is very intuitive. If you ask a random person in a survey, if you ask a random person what is your income, what is your monthly income or your yearly income, it is very evident that he will not give you the exact figure. It's very rare that a person will reveal his original exact figure or earnings, right? It is often seen self-reported income. If you ask a person, he will always give you some misleading answers. They will, never give you the correct answer. Often underestimated value will be given, right? Underestimated values will be given to you. So if we regress health outcomes, suppose this is our outcome variable, health outcomes, suppose this is denoted by Y, on this income which is self-reported, on this income, then OLS will always underestimate the true effect. So this is a kind of measurement error, right? This is the measurement error which is coming from the self-reported income. Measurement error in, computing the self-reported income, this will always have some error. So this thing is happening. We are measuring X with some error, right? Some error, measurement error is there. In our example, we have denoted it by mu I. So this kind of error will happen. Now, if this error happens and still you are applying OLS, then underestimate will happen. What I told you here, that underestimation is taking place, less than beta 1. The original coefficient cannot be estimated. So again, we have to use some sort of instrumental variable. Again, I'll recommend you to pause the video and think what could be a potential IV instrument here. What could be a potential IV instrument? Can you think of something? Here, what we usually do, we use an external data. We use an external data source. For our example, it could be, say, some tax reports, right? It could be some tax reports or some employer reports or salary slip, something, employer reports. So this can be used. Some external data sources may be used as an instrument, for income. right? So we know it is very probable that this income will not be correctly, reported, self-reported. If you do self-reporting, this will not give you some good answers. So what you can do, you can introduce, so the problem of endogeneity will be arising in the model due to this measurement error. Due to this measurmental error, that is why we need to introduce some IV, some instruments. What could be a potential instrument? In this case, external data source can serve as a good instrument for our purposes, right? So we have covered all the three different key sources for which the instrumental variable, need for instrumental variable may arise. So here I have given a summary table. So I wish to, give you the estimation techniques also in this video only, but this video is going very long. I don't want to make this video any longer. So let me cover this summary table today. And in the next video, I'll go into the estimation process. And I'll say, if you have already identified the instrumental variables for your model and you wish to apply that, then how will the estimation process will go? So we'll discuss the estimation process in the next video. I don't want to make this video any longer. So let us do this summary table and then I'll stop for today. So in summary table, what I have given, so all the problems I have listed in the first column C. The need for is, instrumental variable may arise due to omitted variable problem, or due to simultaneity problem, or due to measurmental error, which we have seen in details in today's video. Now, if there is a presence of omitted variable, what happens? What goes wrong in OLS? That the explanatory variable will get correlated. It is very, very likely that the explanatory variable will get correlated with the omitted variable, as a result of which we need instrumental variable. And in case of instrumental variable, here we use IB, which is uncorrelated with W. And I have given you examples also to deal with this. The wage equation example that I have given, right? We have done this. Then in case of simultaneity, what happens? X and Y are jointly determined. Bidirectional causality happens. X and Y both becomes endogenous. That is why the model, if you apply OLS, that will give you bias and inconsistent estimates. Again, we need IB. We use some external shifters. So in our scenario, we have used the input prices as a proxy of the endogenous variable of the milk prices, right? So we have done that. We have seen how to use the external shifters as an appropriate IV in this particular scenario. And third and the final thing that we have done is measurmental error, which contains, so we measure one variable or both the variables. It can, measurement error can be in the explanatory variable, or it can be both in the explanatory variable and in the outcome variable. In that case, some noise terms will be additional. Additional noise will come. In that case, we usually use a proxy, a precise proxy. For our example here, what we have used, an external data source in our this particular example. It can be tax reports or employer reports. As a proxy of income, self-reported income can be, used as an instrument in order to avoid the bias and inconsistent estimates, right? So this is all I wanted to share in this particular video. And in the next video, we will go into the process in which the IV technique works, and we will go into the two-stage least square method that we need to use in order to apply the instrumental variable estimation, right? So this is the agenda for the next video. As of now, if you find this video helpful, if you get anything useful from this video, please do like this video and do subscribe to this channel, An Economist, because this takes immense effort and time from my end to prepare these videos every week for you. I wish to post 2 to 3 videos, long form lecture videos every single week. So if you are getting any benefit from this video, if you find they are helpful, then please support my endeavor and show your love and support towards my channel. Don't forget to subscribe this channel, An Economist, and I'll meet you in the next video with the process of IV estimation. Thank you for your time.